Here's how you prove to your skeptical friend that the true value of pi is equal to the square root of 9.72, and that there's a hidden 3.6-inch circle where degrees and measurements are equal. And what you're going to do this is have them create an example circle. Pick any diameter and label the heights at 75 degrees, 60 degrees, 45 degrees, and 30 degrees. If you don't know how to do this, multiply your diameter by sine 75, sine 60, sine 45, and sine 30. Now create the 3.6-inch circumference circle. The diameter for that circle is equal to the square root of 1.3 repeating. It's 1.15, 4700, 5384. You're going to prove to them that 3.6 is the true circumference for that circle. Now I want you, after you label the heights for that circle at those same degree points, convert those measurements into degrees by multiplying by 100. Because from 3.6 to 360, we multiply by 100. And 3.6 we can also call 360, because just like in money, if $3.6, if we were talking about pennies, that would be 360 pennies, right? So what you're going to do is you're going to take your diameter converted into degrees and divide it by your example circle's diameter. The answer you're going to get is where 1 degree is on your circumference. You're going to take the 75 degree position, convert it to degrees, and then divide it by your example circle's length. You'll see that you get the same answer. You'll do this for each position point. Just for reference, this is the diameter of the 3.6-inch circle, and this is it converted to degrees. So you would take this in degrees and divide it by that circle's diameter. And you would do this for each position. This is the 45 height, and this is it converted to degrees. You would divide this degree by the example circle's height. You'll see that you keep, for each position, you'll keep getting the same answer, and that's where 1 degree is on your circumference. After you do that for each position and get the same answer where 1 degree is on your circumference, take the square root of 9.72 and multiply it by their diameter and get a circumference. And say, okay, if this is the true circumference for this circle, then whenever I divide it by 360, if it equals the same thing as it did for all those other positions from that circle, then it belongs to it, and it will.